Hello, beautiful people. I'm going to go ahead and go over lesson 0.2. Okay, so your lesson objectives today are to practice arithmetic operations on fractions, rewrite the repeated multiplication as exponents, generalize growth patterns into symbolic expression involving exponents. So our lesson opener is the pattern below is the Sierpinski's triangle. We worked on this with our lesson 0.2. So the triangle, the shapes of the triangles and the measurements that those spaces took up. We worked on that yesterday. So we have stage 0, stage 1, stage 2, stage 3, and stage 4 here drawn out for us. So if we look at this, we want to know what is increasing. Well, what's increasing from stage 0 to stage 1, we can see the amount of triangles that we're getting is increasing, right? You can see that for every single one, the amount of triangles. So that's what we're going to say. And the amount of triangles, and specifically, it's the amount of upward facing triangles. So the triangles that are pointing up. Okay, so here we have 3 upward facing triangles. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the amount of upward facing triangles. Okay, what is decreasing? The size of the triangle is decreasing. Okay. What is a recursive pattern? So it's a pattern that repeats itself. So when you think of recursive, no, it's repeating. Okay, so example 1, we are going to refer to the Sierpinski triangle that is up here at the top. And so we want to know, how does the number of new triangles at each stage compare to the number of new triangles at the previous stage? So from stage 0 to stage 1, we go from 1 upward facing triangle to 3. Stage 2, we have 9. Stage 3, we have 27. So let me just mark it here. So we have 1, then we have 3, we have 9. We can see that there's a pattern here. Okay, and I'm only talking about the upward facing triangles. So we have to look at the pattern. We know it's multiplying by 3, multiplying by 3, multiplying by 3. So this would be 27, and this would be 81. So in stage 0, how many upward facing triangles? We have 1 upward facing triangle. Okay, and we just write that as 1. Okay, and then we would just have 1 here. Okay, so in stage 1, how many upward facing triangles do we have? We have 3. And so we would just write that repeated multiplication. It's not multiplying by anything, so it's just 3. So then as exponent form, we'll just do it as 3 to the first power, because 3 to the first power is just 3. So 2, we can write that as, let's just leave that one blank. 2, how many upward facing triangles? We have 9. So then repeated multiplication, that's 3 times 3. And so as an exponent, that's 3 to the second power. Because again, exponents is just repeated multiplication. In stage 3, if we keep following the pattern, there's 27 upward facing triangles. So that's 3 times 3 times 3. So that's 3 to the third power. And then if we look at the next thing, if we follow it, then if we know that there's 27, we multiply by 3, that's going to give us 81. So that's 3 times 3 times 3 times 3. So then that would be 3 to the fourth. And I want to see if you can notice a pattern when it comes to the exponents, so we can now fill in the exponent form for stage 0. I did have us erase that. So if we go 4, 3, 2, 1, and they all have a base of 3, then we can say that the exponent form for stage 0 is just 3 to the 0 power, because 3 to the 0 power is just equal to 1. Anything to the 0 power is equal to 1. Okay? And so it's 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, so on and so on and so on, because this will continue on forever. So to answer C, how many upward facing triangles are in stage 5? Well, if we follow that same pattern, we should know it should be 3 times 3 times 3 times 3 times 3, 5 times. And just to write that, that can be 3 to the 5th power. So to get how much that would be, you can use a calculator, or you can go from our previous one, which was 81, and multiply it by 3. So 81 times 3, that's going to be 243. In stage 6, it's the same thing. So we can write it as 3 to the 6th power. So what you would do is you would multiply the previous by 3 to get 3 to the 6th. And so in that case, it's going to be 729. So there would be 729 upward facing triangles in stage 5. Okay. Well, explain how we could find the number of triangles in stage 10 without counting. Well, we can follow our pattern. We can expand it all the way out, right? We can go 3 times 3 times 3 times 3 times, so on and so on. Or we can use exponent form, and that would be 3 to the 10th power. Okay, you can plug that into a calculator, but that's also equivalent to, what if we started at 3 to the 5th, right? From 3 to the 5th to get to 10, we would need to multiply times 3 times 3 times 3 times 3 times 3. Okay, what if we started at 3 to the 6th power? We would do times 3 times 3 times 3 times 3. And that's all the same thing as 3 to the 10th. And all of that is equivalent to 59,049 triangles. That is how many upward facing triangles would be in stage 10. Without even counting one by one by one by one, we can use the recursive pattern. So pattern that repeats itself. Okay. So let's go ahead and go to the back for example 2. Here we have this different looking shape. So don't get confused with the shape. It is okay. We're just going to go ahead and do the same thing. So we're going to fill out this table. So in this pattern, with each successive stage, only the upward pointing triangles are shaded. So in stage 0, there is one upward facing triangle. The total area for the shaded area is 1. So simplified, it's 1. If we look at stage 2, one of these, right, that's 1 out of the 9 that are shaded. So the area for one triangle is 1/9. And how many of those are shaded? Well, there's 6 of them. So 6 times 1/9 is our total shaded area, but then we simplify it down to 2/3. So in stage 2, okay, and I just want to repeat that this triangle here is the same thing as this triangle, and what we want to know is for one of these. So that's our first step. So if we know the purple is 1/9, how much did we shade for the pink? We shade one of those 9. So it's 1/9 of 1/9. And remember, like yesterday, let's go ahead and write that here. That's 1/9 of 1/9, that's multiplying. So 1/9 times 1/9, that's going to be equal to 1/81. Okay. And of those pink ones that we have here, those hot pink ones, how many are there? They're shaded. There is 6. Okay. And of these 6, how many times does that 6 repeat itself? It repeats itself 2, 3, 4, 5, and 6. So we're going to say 6 times 6 times, okay, and then 1/81. Because we're talking about the little tiny ones. Okay. So now for the next step, this little pink one here is 1/81. But we want to know the even smaller one. And how many of those are we shading? We're shading of 1/9. So 1/9 of 181. So what we're going to do is we're going to do 1/9 times 181. And that's going to be 1/729. And I just left off the simplified section real quick, and I'll go back to that. Okay. Of those little blue ones we shaded, there's going to be 6 of those shaded, times the 6 from the previous, times the 6 shaded from the other previous, times the 1/729. Okay, so you can see that there is a pattern. It just keeps adding. I mean, not adding, we keep multiplying by 6 there. Okay, so then when I go to simplify that out, I'm going to go back, jump back up here. I'm going to have 6 times 6 times 1 of 81. That is going to be 36 over 81. And if I simplify that down, that is going to be simplified down to 4/9. I'm going to divide top and bottom by 9. Okay. 4/9 though is the same thing as 2/3 times 2/3. So you can see 2/3 was right here on the previous. So now we're going 2/3 times 2/3. Okay, 6 times 6 times 6 times 1 over 729. That is going to be 216 over 729. If I simplify that down, that is going to be simplified all the way down to 8 over 27. And again, 8 over 27 is 2/3 times 2/3 times 2/3. And let's just remember, we can represent multiplication as an exponent. So 2/3 times 2/3 times 2/3, that's my base, 2/3. And how many times are I multiplying it by itself? 3 times. For the previous one, that was, my base is 2/3. How many times did I multiply by itself? 2 times. For the first example right here, I just had 2/3 to the first power. And then for this very first one, that would be the same thing as 2/3 to the 0, because anything to the 0 power is going to just equal 1. So we can see we have a pattern there too. Okay, so again, this is a recursive pattern. And just a quick note right here, you could even have written that as, this could have been written as 1/9 times 1/9 times 1/9. We took a ninth of a ninth of a ninth. Okay, so example 3, rewrite 2/3 times 2/3 times 2/3 times 2/3 times 2/3 in exponent form. So your base is the 2/3. How many times are we multiplying by itself? 5 times. Okay. Part B says rewrite 32 to the first power with an exponent other than 1. So 32 to the first power is just 32. So we want to rewrite it with, we want to rewrite 32 as something else with an exponent other than 1. So, okay, so I'm sorry my video cut off, but let's go ahead and finish example B. So we want to rewrite 32 to the first power with an exponent other than 32. So 32 to the first power is just 32. Okay, it's equal to 32. Any number to the first power is just that number. So what we're going to do is we're going to break down 32, and I'm going to do that off to the side, and we're going to do a factor tree. So 32 is 2 times 16, okay? 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So you can't go any further than that. So these are, it's broken down prime factorization. So 32 is 2 times 2 times 2 times 2 times 2, which is just equal to 2 to the 5th power. So 32 can be represented as 2 to the 5th power. And let me make sure that's an exponent. And that's also the same thing as 32 to the first power. All right, so what I'm going to have you guys do for your own, I'm going to go ahead and check. I want you to complete example 4. So please show your work, and I will check these in class when I see you tomorrow. Goodbye, beautiful people. Have a good rest of your day.